This is question 4 of the P2.3 end of chapter test. On screen now is the mark scheme for the question. This is the first part of the mark scheme. Part C follows on the next slide. So please take the time to mark your work. If you got part of the question wrong, I suggest you listen to the rest of the recording to find out how to answer that question correctly in the future. This is part C of the mark scheme, so you might want to use this to mark your work now, and then afterwards I'm going to go through and explain how to do the question for you. In the first part of the question, you've got a circuit diagram, which you can see is here. You've got ammeter 1, ammeter 2, ammeter 3, and ammeter 4. So the table gives the current going through two of the ammeters. Complete the table to show the current through the other two ammeters. So you can see at A3 we've got 0.3 amps, and at A2 we've got 0.2 amps. To work out the current going through here, so if you imagine you've got 0.2 going that way and 0.3 going that way, at this point they both meet. So you can have 0.2 plus 0.3 is going to equal 0.5 amps. Those 5 amps are going to travel around, and you get 0.5 amps there before they split again. So remember, in a series circuit, the current is the same everywhere. In a parallel circuit, the current across each junction is equal to the current before a junction is equal to the current after a junction. So in this case, we've got 0.2 and 0.3 adding together to make 0.5, and that follows the whole way around. So the correct answer is 0.5 amps. So you get 0.5 in both cases, and it's a mark for each. There's an extra mark as well for realising that these two should be the same. So if you've done it wrong, and you've got A1 and A4 being the same number, you get a mark. You don't get 2 marks, but you just get 1 for that case. In the next part of the question, it says which one of the following statements is correct, and you put a tick in the box next to it. And you basically got to work out, is the resistance of the resistor P, which is here, highlight my laser pen to this bit here, that's P, resistance P more than the 20 ohms, equal to the 20 ohms, or less than the 20 ohms. So you can see that going through P, we have 0.2 amps, compared to 0.3 amps going through A3. So if we've got less resistance going through P, then the resistance is higher. Less current, going through P, then the resistance is higher. And the reason for that is that less current goes through P. Okay, remember the lower the current, the higher the resistance. In this question, you need to write down the equation that links current, potential difference, and resistance. This was on your equation sheet. So here you're going to have potential difference, which is V, equals current times R, and that will get you the mark. The next part is for saying calculate a reading on the voltmeter, show clearly how you worked out your answer. So here you have your voltmeter, which is across the 20 ohm resistor. So for that voltmeter we've got R equals 20 ohms. We also had, from a previous slide, we have 0.3 amps going through A3, so I equals 0.3. So to work out the reading on a voltmeter, we do V equals 0.3 times by 20. You can put that into your calculator, second, and you get the answer out to equal, equals 6 volts. In terms of the marking of that question, you get a mark for this bit, and a mark for that bit there, that's worth 2. Then it asks you to state the potential difference of the power supply. So we've got 6 volts across this bit here. There's no other components that will take any potential difference across this branch, which means we must have 6 volts across the branch at the top. So it'll be 6 volts. Alternatively, if you got the answer to question B part 2 wrong, and you wrote this answer as being the same as the previous one, you get the mark as well. So the last part of this question shows you a second circuit with an unknown component labelled X. It says when component X is heated, the reading on the ammeter goes up. So let's try and think about what that means. That means that if the reading on the ammeter goes up, then the current has gone up. If the current's gone up, the resistance has gone down. We need to now think about a component that's resistance decreases as temperature goes up, and you should think that that is actually a thermistor. You could draw on the thermistor, make sure the arrows are touching, and you got a mark for that, so it's 1 mark for thermistor, and the second mark is for explaining why. The reason that it has is that for current to increase, resistance has decreased with temperature. I haven't got room to write temperature, I'm just going to write temp. So the idea that as temperature increases, I should have put there. So the idea that as temperature increases, resistance decreases, and that's the thermistor, gives you the second mark. So that's out of 2. And that brings us to the end of that question.